Waste incineration has been an alternative to city dumps, but they also haven't been without their problems. While less methane is emitted, cancer-causing dioxins are created. However, the latest generation of waste-to-energy plants like the one in Russia developed by Greenlight Energy Solutions seems to have solved that. It can process just over 300 tons of raw municipal waste every day, including recyclable materials like glass and metals filtered out at the pre-processing line for further sale. After sorting, the remaining trash passes through a shredder and a dryer where its water content is taken down to 20%. Then it's fed into the specially designed pyrolysis chamber. Thanks to unique technology, Greenlight Energy Solutions is confident that it's much better for our environment than any other waste-to-energy plants that have come before it.
This technology is unique as it allows energy to be produced from waste in an environmentally friendly way, without any toxic or polluting fumes discharged into the air, without any toxic residue at the end of the process. This technology is also cost-effective. It produces much more energy than it consumes to keep running.
Unlike typical trash-burning facilities, this one currently located in the Moscow suburb of Voskresensk uses high-temp pyrolysis, which means the trash isn't actually burned, despite temperatures reaching up to 850 degrees Celsius. The waste isn't incinerated because there's no oxygen in the reactor. Since the trash is heated indirectly, the waste materials are reduced to syngas and a carbon residue, which is between 2 and 10% the mass of the original trash that entered the chamber. And thanks to its combustion-free methodology, there's no residual and fly ash to pollute the area around the plant. But in order to do that, a different kind of chamber had to be developed.
The main difficulty we faced was to produce a proper cast-iron reactor required for incinerating the waste. It needed to be made of material which would be both wear-proof and heat-proof, and such materials hardly exist. We developed a special formula of cast iron that has never been produced before, as simply no one could do it till now.
But after a good amount of searching, Petrozavodsk-Mash stepped up to the plate to create the specific type of cast iron Greenlight Energy needed. In induction furnaces, 8 tons of iron are smelted. Into the liquid mass, alloy and aluminum are added, something which had never been done before. The whole process has to be done pretty quickly because aluminum dregs can stick to the walls of the furnaces. For each pyrolytic reactor, Petrozavodsk-Mash pours the metal into 8 sections, lids, and other affiliated parts. The result is a new type of extremely heat-resistant, high-alloy cast iron. While keeping track of everything going on at the plant could be extremely complicated, a state-of-the-art computer system allows the workers to control just about everything with a simple click of the mouse. From the control room on site, all safety indicators can be monitored and all actions can be easily regulated. Such safety controls are especially important since the oxidation chamber burns the resulting syngas at 1,200 degrees Celsius for 2.5 seconds. These extreme temperatures are needed to destroy all harmful toxins like dioxins and furans. From here, the oxidized gas is converted into high-temp steam, which is used to spin turbines and create a renewable source of energy.
5-7 megawatts is a lot of energy. Since one line is able to produce about 45,000 megawatts per year, that could help us to provide about 10 to 20,000 homes with electricity, light and heating, depending on consumption rates and standards.
In addition to that electricity, it also produces another economically viable byproduct, carbon char. Because it doesn't contain those nasty dioxins and other toxins, it can be sold on as an environmentally clean product for making things like fuel and asphalt. Since this technology significantly reduces the emission of greenhouse gases, it could also be used to generate up to 1 million carbon credits under the Kyoto Protocol.
The first unit is to be placed in Chekhov, another one in Voskresensk, and then Mytishchi. All in all, they plan to have 30 plants in Moscow and the Moscow region.